Hey guys, it's Simon and welcome back to the Kotlin RPG LibGDX tutorial series. So in the last part we created an animation system, so now our player and also our slime play an animation. I think for the slime it was the run animation if I remember correctly, and for the player it was the idle animation. We also have some rendering going on with the viewport already, so if we would have like a device with such a screen resolution, then we still have the same aspect ratio of our sprites and our world simply gets extended. So if there would be an entity here, we would now see it, and if our device is just like that size, then we won't see an entity like here. So this is happening all with the viewport. We have optimized our rendering with the texture atlas so that we only have one texture binding. And in this part we are going to improve on our little scene here, because at the moment it's quite boring. We just have a black background and some entities there, and in this part we are going to introduce the tiled map so that we have some map in the background. And we will also make a split between the background layers of the map and the foreground layers, so that entities then are either in the back or in the foreground of certain map objects. Okay, but before we start into that, I forgot to mention one thing in one of the last parts regarding the entity component system. So people might wondering what exactly was an entity. I never mentioned that, and an entity is quite simple. It's just an integer. So it's a Kotlin value class, which from what I know is simply like a wrapper, but not really a wrapper about the type that you give to it. So the representation in the bytecode that comes out in the end, so the Java bytecode, will be simply an integer. There is no overhead. It's really just an integer, but it has the advantage that first of all it has a more meaningful name. So I found it confusing, or not confusing, but not ideal in Flex if you simply just get integers for the entities. So that's why I introduced this value class there. And also in theory, it's then easier to make extension functions for your entity, because if you write an extension for an integer, then every integer would have that. But here we want to split between an integer and an entity. But in reality, an entity is just a unique ID in your world. And like I explained it in a previous part, so there are some arrays in the background of an entity component system, for example, to identify which entity has what components and things like that. And for that, an entity simply needs to have a unique ID to know in which place of all those arrays it's located. So that's it. I forgot to mention that. And with that, we are going to introduce now the tiled map support. For that, we are going to use a program which is called Tiled, which is that one. I will add a download link to the video description below again. Let me quickly search it in Google. So I think it should be that one exactly. So there you can download it. It's for free. Which I find very impressive, because it has actually a lot of features and functionalities, and it's really amazing. And I have no idea why people give that away for free, but it is for free. And if you want, you can donate, of course, to support the people who are working on that. So how does it work? Here you see an example of the final outcome, so the final game that I presented in the first part. So those files always have this TMX ending, so it's a tiled map. I don't know what the X stands for, yeah, but a tiled map file. Map can have different layers, which you see here on the right side. So for example, I have a ground layer for all the ground of my map. Then I would have a background layer. Let me disable first of all everything. Then a background layer, which we will identify in our code. So there we need to have a special naming convention, and all those things which are part of a background will be rendered in the background of our entities. Then we will have foreground layers. Those are simply things which are in front of our entity. So for example, a part of a tree, so that when an entity goes behind that it really disappears behind the tree. And finally, but that is not what we are doing in this part, that we will introduce in the next part, you can have a so-called object layer. Let me show you quickly that. So there is a tiled layer. I have it in German, which is a little bit unfortunate, but I will translate it. So there you have a tiled layer, which is like all the other layers, so the ground, background, and foreground, where you can place a specific graphic for one specific tile of your map. Then we have object layers. So like here, for example, our entities are object layers. And what we are going to learn is then when you place such an object in the map, then it simply gets loaded and the entity in our game is created out of that object that we place there. Then you have picture layer. There, from what I know, I never used it, but from what I know, you could place an entire picture into a layer. For example, if you have like, I don't know, a huge background picture like the moon or whatever, so big pictures, then you can place that in the so-called image layer. And then there are also group layers so that you can group layers together. So I also never used it, but if you would have a very complicated map with billions of layers, maybe not billions, but a lot of layers, then you can group them together if you want. And I would say those are the basics for now. We will of course create a map from scratch. So let's do that. Let's close this map and discard all the changes. So we will create a new map as mentioned. Then the format will be, I always choose a different one, but normally I think I use base64 with the CLib compression to make the map a little bit smaller. At least this is what I assume. I actually have no idea what that is. So CSV, I would assume it simply stores then all the map data in CSV format, so easily readable and also hackable by other users then in the end. With base64 it's then simply compressed and I guess not so easy to manipulate, and also the file size will be smaller. Then you can choose if you want to have a fixed size map, which we are going to do. So we will have 32 by 18 tiles, but you can also have an endless map. So that would be this limitless, I guess it's translated in English. So then you don't have any boundaries. Then you can simply draw in the dimensions or size whatever you want. And I never used that personally, but I would assume still you have of course a size. So whatever is your most right, most top, most bottom, and most left tiled, that will be then the final size of your map. But in the end, it's an endless one, so you are not limited by a specific size. But we keep it simple. We have a fixed size. And then you need to define the size of your tiles. And from our last part where we downloaded the Mystic Woods tileset, let me simply check that. So there we have the sprites, we have the tileset, and in there, yeah, so there I already see it. So the decoration is 16 by 16. So I assume all the other tiles are most likely also 16 by 16. So let's choose that one and say okay. Which brings us now to our map. So there we have our different tiles. Currently everything is empty. We don't have a tile set, so we cannot draw in our map. You could in theory add now some attributes or properties to your map itself. So that one you can do, for example, with that. So add an additional property. You can choose the type. We will later on use that to load a music file and play some background music for our map. So as an example, you could here have, for example, map music, which is a string. So that would be the key of the property, and the value would be then in our assets folder, for example, audio map 1, I don't know, background MP3, for example. So this is how you define properties in Tiled, and it works the same. So you can, for every object that you have there, so you can add properties to the map, you can add properties to a tile, you can add properties to the tile set that we created a moment. I think also to the layer. So almost everywhere you could add properties. So you are very flexible there. You could define special background colors, if I remember correctly, for certain layers or highlight them, but that is not what we are going to use. So for that, please read up the tutorials in Tiled. I'm really only covering now the basics that we are going to need for our game. So for us, the important part is the tileset. So we create a new one by clicking here, and we will base it on a specific tileset and give it a name. So for example, this is the map tileset. And then you need to provide it with a graphic, so a texture, let's say, which contains all the different tiles. And here again, I don't have a perfect workflow for that. And the way I'm doing it is similar like I did it in the last part with the player and the slime. So I would simply split up the graphics that I get from itch.io, and with image magic split it up into different frames. So these 16 by 16 frames in that case. And then with the texture packer UI, I simply combine all of them together, which is not ideal because I lose the ordering. So as you see here, so for example, that graphic, as you see it here, will not appear like that in my tile set. So I have then a random order of these tiles, which is very annoying. But unfortunately, I don't know how to do that better. And you might wonder, Simon, why are we not simply taking the graphics as we have them here? Because they are already perfect. We can simply split it up, use it. Let me show you how we could do that. So just quickly, let's go here to the tile set and pick, for example, the decoration. And here we define, so it's a 16 by 16 tile graphic, and we have no border. So this is the border from the edge, so the edge border of our graphic. If we would have that, padding, I explained it then in a couple of minutes, and this would be the padding between two tiles. And with this normal graphic, we don't have that, so it's 0 and 0. If we add that, it looks great, so we can click on that. We can also draw with that, and you might think, hey, this is exactly what we want. Isn't that already amazing? It would be amazing if it works easily like that, but unfortunately for me, it never didn't. There is something which is called texture bleeding. And when it comes to rendering, so if you would draw a map like that, and then we learned that in this part, when you render it then with LibGDX, and you move the camera around, because our player will then later on, of course, move, then from time to time, you will have like little lines, normally vertical, but can also be horizontal lines, which does not look nice. So that there seems to be some problem with the rendering. So you usually have then the background color of your game, which by default I think is black. You will have then some black lines vertically or horizontally from time to time when you move around in your game world in LibGDX. And this problem is called texture bleeding. And the problem is that for whatever reason, don't ask me why, but for whatever reason, when OpenGL has to render those little tiles, so these 16 by 16 tiles, then sometimes it's not accurate enough, most likely because the camera does not have integer position, so it's not always 0, 1, 2, 3. The camera position could be 0.234, and the y coordinate could also be some floating number. And with that, I guess there are some rounding issues from time to time, and then it cannot cleanly draw that small tile, and sometimes then goes overboard and maybe takes the 1 pixel of the next tile already, which is to the right or to the bottom or whatever. And then you get those artifacts in your rendering problem. I tried to find a picture now in Google to show you what I mean, but I hope you understand what I tried to describe. But let me see if I can find an example on Google. Okay, perfect. I could quickly find something on Stack Overflow, and there you see exactly that problem that I meant. So there, a guy, it seems like he has a tiled map and is rendering everything in LibGDX, I guess. And there you see he has now this vertical lines here, which are not nice. So he doesn't have that on the left side, but here, for example, he has them. And that problem is called texture bleeding. And that problem occurs when you don't have a padding between your tiles. So when your tiles are directly next to each other, like we have it in the original graphic here, then you have this texture bleeding issue. And to avoid that, what I'm always doing is that I simply add a padding between those tiles, and then it solves that issue. And usually when I have very small tiles like this, for example, with 16 by 16, then I use a higher padding. I'll show you that in a moment in the texture packer user interface. So there I normally use 6 or 8 or at least 4. And if the graphics are bigger, so for example 32 by 32 or even higher, then usually a smaller padding, at least for me, was always sufficient. But because of that problem, we unfortunately cannot simply use the graphic here. If someone out there knows a better solution for that, then please let me know. My solution I'm going to show you now. So let me remove this tile set because that is not working. And I simply take over now the graphics that I did for the GitHub project so that you see that. So there I have created a map folder. And in there you see I have, with Image Magic again, I created or split up the original graphics from itch.io in the different frames. I also gave them some naming, which I think is not even necessary because it's anyway, unfortunately, combining them randomly and I lose the order of the original graphic. But here you see, for example, we have the decoration graphics. I also removed the empty images that would have been created. Then I also split up the objects. So for example, the trees that are in a different folder. And in the end, I have those different tiles. So let me simply take that now over to our project. And let's open up our texture packer project from last time. So for you, just take the graphics maybe from the GitHub project, or if you have a very nice workflow how to create those and you are smarter than me in that case, then please also let me know in the comments. Would be appreciated because this is one of the most time-consuming parts every time I create a game, and I hate it so much because it's really, it's not that nice. It's just time-consuming and annoying. Okay, so we need a new texture atlas. Here, let's call it let's call it map. A new pack. We could theoretically also combine that with our game objects if we have enough space in the original texture, but I like to split that up and keep it differently. So I have usually a map texture atlas and then another texture atlas for all the game objects, which are not really related to a tile map. The output directory is again our assets folder. Let's store it in there. And the folder that we are going to use is now this map folder that we saw before. That would be already it. So when I pack it now, okay, that's maybe a little bit too big. Let's make it a little bit smaller for tile because it's not so nice when we have then a huge tile set and we need to scroll horizontally so much. So let's make it a little bit smaller. Yeah, that looks good. So those would be the different tiles. Let's also remove the padding that you see that quickly. So with that, we would have now the different tiles that we can use for the drawing. And as you already see, unfortunately, we lose the ordering of the original graphics. So for example, if I want to draw a tree, I really need to find the different bits and pieces which is not that nice. So someone suggested me once that I should simply create my own tileset in an image program. But there, since I always need to adjust the padding usually and try out with what kind of value I get rid of the texture bleeding issue, it would be, again, for me, since I'm not a graphics expert, it would be a super time-consuming task to always recreate that patch. Maybe I should create a tool once that makes it for me, because I guess it's not that complicated to simply split out different frames of an original graphic and then combine it again into a new one with padding. I guess that is not that complicated. But yeah, for the time being, we work with what we have. So if we now would use that texture atlas, we would still have the bleeding issue. And to get rid of that, as mentioned, we need to introduce some padding. So for example, let's take a padding of 4. If we now pack it again, you can now see that there is some padding between two tiles. And with that, we get rid of the texture bleeding issue. So that is the solution to that. There are also additional solutions. So for example, if we use a duplicate padding, then as you can see, then the edge pixels are copied into the padding. So let me show you that. So now the texture bleeding problem would be, from what I know, even be better solved, because now the padding between two tiles still has the pixels which are on the edge of the real tile. So if for whatever reason, again with the rendering accuracy, it would pick up something slightly outside of the tile itself, we would still keep the original pixel color of that. So that is also a great option which I always use, so the duplicate padding. So again, just to show the difference again, so without the duplicate padding, then you simply have transparent pixels between two tiles, but with the duplicate padding, then it uses the pixels that it finds on the edge of a specific tile and uses it for the padding of that specific tile. Okay, then this bleeding option, I also keep it enabled usually, which helps. And I think that's it. I found, in my opinion, a bug, and I also reported that, but unfortunately the guy on GitHub really didn't want to help me there. He just said, yeah, do something else and don't use that. That was basically his answer. When I use a grid layout, then you see, hey, Simon, we have an ordering again. So the fences would somehow be together, the tree would be together again, and it would be great. It improves on what we had before, but let me remove the duplicate padding, because then it's easier to show it to you. If you notice something, for whatever reason, the padding at the top now is way bigger. It looks like it's twice the value that we entered for the y coordinate. Don't ask me why, but with that special offset, so since it's not the same from the top and between the tiles, it's then not usable within the TiledMap editor. I also showed it in a moment, but yeah, unfortunately for me, it's a bug that the grid layout is doing that. But yeah, as mentioned, the guy on GitHub did not want to help me, so we have to disable it. And now when we go back, you see now the difference again. So now the padding from the top edges, it's now the same again, and it's correct with the value that we entered there. And for whatever reason, the grid layout destroys that. Okay, so now we have our graphic for the map. So we also got rid of this texture bleeding issue. Now let's import it into Tile, because now we can use it and we won't have any rendering issues with LibGDX. Okay, so now that we have our texture ready, let's also, I quickly checked what values I used in the real project. So I used there a padding of 6, so let's also use that one. So I also learned sometimes that entering the number here won't work. So yeah, let's use the sliders and also use the 4 square, which makes then a a square texture, which is also a little bit nicer to work. So let's use it like that. And now we want to use it in tile. So what do we do there? So when we create now a new tile set, let's pick the map graphic that we just created. And now for the edge border or edge padding, it's actually half of the value that we used here in the padding, so it's 3. And for the padding between two tiles, there it's the value that we used in the texture packer user interface. So there it would be 6. And with that, we get now our graphic, and there you see now, so you don't see these edge pixels or whatever we used for the padding. So there you really now again see the original graphic. And to explain that with the padding, so let's quickly go there. So as you see from the edge of the texture itself, it's the padding value, but just once. So the value that we add here, so this value of 6 is the padding between two tiles. So there you see there's something to the right of this red rectangle, and there's something to the left of this red rectangle. And the padding between those two rects is a value of 6. But to the edge itself, so to the edge of the texture, as you see, it's just 1 or half of that value, because it's just 1. So there is no other tile up here or here. So that's why it's just half of that value. And that is why we use those values in tiled to get now our tiled map. Okay, then let's now create some tiled layers. So the first one, let's call it ground, and there we, for example, fill it out with grass. So there we can use this bucket and then fill our background. Then maybe to make it a little bit more exciting, we can pick also some other tiles from the tile set and bring a little bit of a variance into that. Okay, I see. So those here are in this dark green. So let's take the dark green grass, and now with the stamp, which I think is that one here. So now let's place randomly some other grass tiles for our ground. So I'm not the most amazing map designer, but just that we have a little bit of a difference then in the end. Okay, then we want to create a new layer for our background stuff. So let's call that background, and then, for example, 1 for the background layer 1. And here, for example, we could make a little fence. So let me quickly draw something. So for example, that one. Yeah, let me quickly draw something. Okay, so something like this, for example, for our background. So there we have this little fence. Then let's also create a foreground layer. So something that is drawn in front of our player, and there we would have a tree. And here comes the annoying part. So I need to find the different tiles which combine a tree. Let me quickly also find that out. Oh, and I also see for the background we can also use, for example, a stone. Let's make the scene a little bit more exciting. Okay, that looks a little bit like a tree. I think I found something. So what I'm going to do, so the bottom of the tree, let's cut that out. And that one we actually bring into our background. So let's make one tree here and one tree here. And the foreground of our tree, so that is then in front of our entities. Let me cut that here, and they are really part of the foreground. So that one we are going to render here. And for example, here, so that is a small tree. And I think that's it for now. It does not have to be super exciting. You can enhance on that. Yeah, that would be it. So let me also bring in here some dirt. So now I'm really happy. Then let's save this map. So there we create now a new folder. Let's call it map. and this one would be our, I don't know, map 1. Perfect. So the next thing that we are going to do now is to load this map into LibGDX and render it. So for that, we go to our game screen class. And there, when our screen gets shown, where currently we also create those entities. Let's create the world up here. So there is something in LibGDX which is called the TMX map loader, which, as the name suggests, loads a TMX file, which, as we learned before, is the file format of tiled, for example, for those tiled maps that are created. And there we are going to load a map which sits in our map folder, and we called it, I think, map 1 exactly. So we are going to load that map. And what we also need to do, we need to render now this map. So this is not very exciting. So this is simply loading the so-called TiledMap in LibGDX. So if it can load that successful, but with that, we don't do anything. So this just contains all the information. So the different tiles, what kind of tile is part of each cell, the different layer information, the properties information. So all of that is part of the tiled map. But if we don't do anything with it, then it's quite useless to load it. So we going to introduce the rendering in our existing render system. And this system somehow needs to know that we are going to change or load a map. And the approach that I choose for this example application is that we are going to use the event system that comes with Scene2D. So this is again an advantage. If you use Scene2D, then you automatically get an event system. So you can fire certain events, like in this case, we are going to fire a map change event, and then certain objects, so so-called event listeners, can react to those things or those events. So for that, we are going to create a new package that we call event. Let's create there a new file. In this file, we are going to create a new event class. So in that case, it's a map change event, and it takes in the tiled map. Let's call it map, which is the tiled map that was loaded. Could be even a data class. Then one small thing, let me quickly show you that. So here, for example, we would now call stage and we want to fire an event. But unfortunately, there is no fire event on the stage itself. It's always staged and the root, so the root actor of our stage, and there we can fire now an event. And I don't like that I have to write stage root fire all the time. So what I did there, and for me it made more sense that way, is that I simply created an extension for the Scene2D stage where I can fire an event directly on it. So we will define a new extension function for our stage. Let's call it fire. And it takes an event from Scene2D. And that one is simply doing from the stage, it gets the root element and fires the event. So it's as simple as that. And with that extension, we can then write stage fire. And here we are going to fire a map change event. And the map is the one that we loaded up there. So let's store that in our TiledMap variable and pass it into our event. Oh, and sorry, map change event, of course, needs to extend from the Scene2D event without any special information so that we can really use it for the event firing. So some of you might ask, why are we simply creating an event like this? Because in my previous tutorials, I always introduced the concept of pooling. For people who have never heard that, the concept of pooling means that whenever you don't always create objects newly, So like in this case, whenever we would call a fire event that way, we would always create a new map change event object, which then of course gets cleaned up by the garbage collector once it's not referenced anymore. And that, at least in the past, or maybe nowadays too, if you have a lot of those objects that get cleaned up by the garbage collector all the time, you will have some stuttering in your game for a brief moment because of this cleanup of those unneeded objects. And in the past, I always made a big focus on such performance things, let's say, or memory topics in that case. But it always gets a little bit more complex when you introduce such concepts. And for the small games that I developed so far in the past, it seems like this is not needed. So the garbage collector nowadays and also the hardware seems to handle it quite well, what I am at least doing. So for me, it's not necessary to introduce pooling. Again, so what would pooling be? So instead of creating those objects always new, you would have a pool of those map change events, and you can obtain an empty object out of that pool, so an empty map change event. Then you modify it, use it, and once you are done with it, then you free it. So you put it back to the pool, which means that whenever you need another map change event, the pool looks up, so do I still have some empty cleaned up objects that I can use? Then the obtain function would give you back such an already existing object, and you can use that again. So instead of creating new objects all the time, you will have a growing pool of those object types, unless you have a certain cap, and you are going to reuse all the time the objects that you free back to that pool. With that, the garbage collector never needs to clean up anything because you always keep such empty references in your game. So you have a little bit higher memory footprint, let's say, but you don't need to have the garbage collector to clean that up. But again, for me, at least in my games, it was never a problem, and it's simply easier to write something like that instead of pool.obtain map change events, then maybe with apply, modify it, and do things like that. So as long, my suggestion, as long as you don't face any issues in your game performance-wise, then just go with whatever approach you choose and which is easier for you, and don't let you confuse or let you tell you something different from other people. So that's why for now, for this tutorial, we don't use pooling. If you want to read more about it, I will also add the link in the video description below. But again, for now, for us, it's simply creating this map change event, and that would be it. Just to give an example, so if you would have a system that runs every frame, I don't know, for example, the movement system, and every frame you would fire a move event, that could maybe cause a problem, because then you are creating, for example, 60 events per second if your game runs with 60 frames per second. And the garbage collector then always needs to clean up all these events that you are creating. Not saying that it's a problem. I don't know what is actually the problem or the amount where you might notice some stuttering in your game, but that was the reason why this pooling concept was introduced by LibGDX. Okay, so back to our stage. So we fire now an event, but since no one is reacting on that event or listening to that event, also that call at the moment is useless. But we want to react on it. So our render system is going to implement a new interface, which is called an event listener of the scene2D. And there we need to implement a method, which is called handle. And there we are going to get an event, and I assume the event can never be null. So let's remove that question mark here. And now we want to check something. So when our event is a map change event, then we are going to do something with that. So there we have now the map that got loaded, and with that map we are going to do something now. And also we need to return a Boolean, and if I remember correctly, the handle method needs to return true if the event should be considered handled by scene2D. So I'm not 100% sure, but if I remember correctly, I simply return here always true. At least in that case where I handle the event, and in all other cases where I don't, or where we don't handle it, we return false. And here we need to return the method. Okay, so like this. When with subject shall be used. Ah, okay, so that's even cleaner. Perfect. Thank you, IntelliJ. So what we want now in our render system is that we want to render the tile map, and we want to distinguish between a background layer and a foreground layer. So what we need to do is that from our event, from our map, we iterate over all the layers that our map contains, and there are different layers. So as I mentioned, there's an object layer, an image layer, and a tiled layer, and we are interested in our tile layers, because those are the things that we are going to render. And for every layer that we have there, we now need to check if it is a foreground layer or a background layer. So we simply check if our layer name starts with foreground, for example. So foreground underscore, this is what we used for our layer in here. So this foreground underscore and then something. So if it is that, then it will be a foreground layer, and otherwise it will be a background layer. And for the rendering, we need to remember what is a foreground layer and what is a background layer. So we are going to store that in a collection. And for that, we are going to define that here. So we have a background layer collection, which is simply a list of TiledMap tile layer, and we also have a foreground layer, which is also simply a list of TiledMap tile layers. And whenever a map changes, first of all, we are going to clear them so that we don't have any reference to an old map. And here now, so if it's a foreground layer, we add it to that list. And if it's a background layer, then we add it to that list. Okay, so now our render system is an event listener, and it would react to a map change event. But we also need to register it now to scene2D, so that scene2D knows the render system is listening to certain events. And we could do that in the constructor, of course, of the render system. But I don't like that a lot, because you could forget to do that. Of course, you will notice it because something is not working. But in this tutorial, we will have some other systems which are also event listeners. So that's why I prefer a generic solution here. And what we simply do, so in our show method, let's do that here because we need to do that first. From our world, we get all of our systems. And for all of these systems, we are going to add them to the stage as an event listener if they are event listeners. So for every system, if the system is an event listener, then we are going to add it to the stage as a listener. And that's it. So with that, we have a generic solution. So any system that will be an event listener will be added to the stage. And now all of that is working. So now we load the map, we fire the event. That will then call from our render system the handle event method. And the only thing that is now missing is the rendering of our map. And the rendering of a tiled map, the tiled map that we are going to use, is supported with a so-called TiledMap renderer in LibGDX. And for that specific one, we have an orthogonal tiled map renderer. And that one takes a tiled map, which we don't have at the moment when we create this map renderer, so it will be null. And the sprite patch that we are going to use is the sprite patch from our stage, so that we so that we can reuse that. And as you notice, there's also a unit scale in it, which we are going to use, because that one is scaling down the map, which is usually rendered again in pixels. But we, as you know it from the previous part, we are working in our game world units. And there, usually I take the unit scale according to the tile size of my map. So since we have a 16 by 16 tile size, our unit scale will be 1 divided by 16. So that is then the scaling, that one tile in the map refers to one unit in our game world. If we would have here, for example, 32, then it would simply mean that 2 tiles are 1 unit in our game world. But for our game world, 16 pixels are one unit. Good. And the last thing now is that we are going to update our render logic here. So here we are only rendering the stage, but now we want to do something else. So before we render our stage, so our entities, here we want to render our background layers of the map. And after we are rendering the stage, we are going to render the foreground layers of our map. So what we are going to do is, from our map renderer, we need to set a view. So what portion of the map will be rendered to the screen. And there we are going to use the camera from our stage. And it is always an orthographic camera. So let's optimize that a little bit. Instead of doing this cast here all the time, let's just do it once. So also the camera of the stage never changes. So let's store that here. And this is simply the game camera as an orthographic camera. Exactly. And then we can use that here and don't need to cast it all the time. Good, then we are going to check, so do we even have some background layers? So when the background layers are not empty, then we are going to render them. And for that, we again have from our stage the patch. And then we have now this use extension function from LibKTX. Then again, our sprite patch needs to know in what kind of matrix or what kind of view we are going to render. So there we are passing in the combined matrix of our camera. And then for every background layer, simply we call from our map renderer the render tile layer function and pass in here the layer. So that should be it in that case. Okay. So you might wonder, what is that use? I think I did not cover it yet in that tutorial. So what use is doing, and this is also basic OpenGL stuff, whenever you are going to render, you need to call first of all this begin, which tells OpenGL, okay, now I'm going to make some draw calls. Then you can do as many draw calls as you want. And then you end it, so which means, so now the current render calls are done, and put it now on my screen, for example. And of course, before you start the rendering, you need to tell OpenGL, for example, in your words, what is my position, where am I looking at, is there maybe some other transformation and scaling and things like that, and rotations happening. So this is part of this projection matrix. And the use function from LibKTX simply is a wrapper around that. So coming back to our original code, so here we say what kind of matrix we are using. So again, the translation, rotation, and scaling information. Then we have out in the background this begin and end call, and we simply need to make the render calls that should happen between this begin and end block. So that is the magic, let's say, behind this use function. Okay, and then we simply have the same after we rendered our stage. So there we have our foreground layers. Again, we check, do we even have them? And then we just take over the code from above. So again, we are going to render, Again, we used from our camera the combined matrix, and now for our foreground layers, again we call the MapRenderer function and render the tile layer. Okay, just that you have heard that, so there is also a render function of the map renderer itself, of course. What that does internally, it simply goes through all the layers of your map and renders then the map layer. And depending on what kind of layer it is, so it could be a map group layer, then it's rendering the group in a specific way. It could be a TiledMap tile layer like we have it. It could be this image layer, and otherwise it's this render objects, where it's rendering the objects, which basically does nothing. So an object layer is not rendered. But yeah, so that would be a single call. But the problem with that is that we can then not distinguish between a background and foreground layer, and the entire map is simply rendered at once. And since we want to distinguish, we need to make it like that. So we really call the render tile layer function directly with the layers that we want to render. Okay, and the last piece, so a small one that I did not mention yet. Let's remove that call. There is something which is called an animated TiledMap tile, and there we need to update our animation base time. So what is that? There is a specific function in Tiled. We don't have that yet. Let me quickly go to the editor here. So you could, for example, have water tiles or a waterfall tile, and there you have an animation in your tile map. And for that you can use the animation editor in Tiles. And let me just quickly create an animation which does not make sense, but for example the first frame would be that one. Sorry, first you have to select the tile. So for example, I don't know, let's make this green grass here. Then we go into the animation editor, and then the next frame would be, for example, the light green grass, and the next one would be something with a dirt, and the time between those two frames. So in the end you would get out an animation. So as you see it here, so it's looping through that animation. And if you would now place such a tile in your map, then of course the animation is playing as well, and LibGDX covers that, so it already could render such animated tiles, so that is not a problem. Let me revert that. And in order for that to work, it needs to you need to call this update animation base time. So because the animation in the background, how it's handled, also has a time similar like we used it with our animation in the last part, and you need to move forward in that time to play the animations correctly. I think the original render call does that internally, but since we don't use it, we need to call it manually here. So let me quickly check. So render, begin render. Yes, so there it is. So in the begin render, it does this batch begin call, and then it does this update animation base time. But since we never reached that specific code because we handle it in a different way, we need to call it here ourselves. We don't use animated tiles, but if we ever want to use them, then it would already work with that piece of code. Okay, and with that we should hopefully now see a map. Let's see. And we do! I'm always surprised when something works on the first try. So what we have, so we still have our player and our slime, of course, like we had it before. And now we also have our map with the correct scaling. So as you see it here, we are starting from the bottom left with the rendering and then go up. So here we have a little bit of our fence. And here, as you see, so if we go above this 16:9 viewport, again an example, we simply see more of our game world. So the minimum is the 16:9. So if we are smaller, then also the rendering simply gets smaller. But if we would have a bigger screen device, then we simply see more of our world. Okay, perfect. I think, yeah, that's it for that part. So it was a lot of information. again. I hope it was not too complex. Play a little bit around with the tiled editor. Also read up this texture bleeding topic if you are interested. And in the next part, we are then replacing the entities that we currently manually create in our code. We write there then some generic logic that we load such entities with our, out of the tiled map. So there we are going to use the object layer. Then we can freely place around our entities, and our logic will take care of correctly creating them. Okay, thanks for watching. Have a nice day and bye-bye. Oh, I forgot something. I just remembered that. The map renderer needs to be disposed, of course, as well, and we forgot that. And now comes one of the advantages of Flex. So since we are creating this resource in our render system, we can now simply override the dispose method. And in here, we simply dispose now our map renderer. And since in our game screen, we call the world dispose method here, that then also calls the dispose method of each system, and we end up here. So the resource that gets allocated in our render system also gets cleaned up here. That piece was missing. Sorry for that, but now that's really it. Thanks again, and bye-bye.